Okay, so we're going to continue with subtopic 6.2, equilibrium constants. So equilibrium constants that you have will be Kp and Kc. So we'll see how we can use Kp and Kc to solve our equilibrium problems. Alright. In this part's learning objectives, we'll cover how to define homogeneous and heterogeneous equilibria, and also write expressions for your equilibrium constants in terms of concentration Kc and partial pressure Kp for homogeneous and heterogeneous systems. So I divided 6.2 into like short parts so that you won't be tired. Okay, so first we're going to define homogeneous and heterogeneous equilibrium. So you know homo maksudnya sama. So that means that all products and reactants in your system are in the same phase, right? So you can have all your products and reactants in aqueous phase. So if you have aqueous phase sahaja, then you can express your equilibrium constant as Kc. If you have gaseous phase only, then you can express your equilibrium constant as Kc or Kp. Okay? So K is a dimensionless unit, like I said before. So it has no unit because when you do the ratio, you will cancel out the concentration units or your partial pressure units. Okay? Heterogeneous equilibrium pula, hetero meaning it is not the same. Therefore, it is achieved from a reversible reaction involving reactants and products that are in different phases. So you have different phases. So bukannya aqueous je, bukannya gaseous je. So ni aqueous EQ, ni gaseous G. Okay. So maksudnya it has a mix of aqueous ke, gaseous ke, or liquid or solid. Alright. So the concentration of pure substances, i.e. liquid or solid, is constant. So its concentration is not included in the equilibrium expression Kc and Kp. So if you have a liquid or you have solid reactant or product in your chemical equation, in your reversible reaction, then you are not going to include them in your Kc or Kp expression because their concentration stays the same throughout the reaction. Therefore, it has no effect on your equilibrium constant. So you're not going to include liquid or solid, okay? You're just going to ignore it as if dia tak exist. Alright? Let's try to write down the equilibrium constant expression. So in terms of concentration, that means Kc, and pressure Kp. For this reaction, homogeneous equilibrium here in this reaction is in gaseous phase only. So if you have gaseous phase, that means you can write it as Kc or you can write it as Kp. So to do your expression for Kc, you will use the squared brackets to represent concentration. So you're gonna write the products first. So you have SO3 concentration, and note that you have this stoichiometric coefficient, the number of mole, you have 2. So you're gonna write 2 there. Over your reactants, you have SO2 concentration. Okay, square it because you have 2 right here, and then you have oxygen. Okay, right. So in this case, I included all because it's all in gaseous phase. There's no solid, there's no liquid. Okay, so that is your Kc expression. Okay, how about Kp? You're going to write the partial pressure. So partial pressure of SO3, then letak squared over partial pressure of SO2 square, and then partial pressure of oxygen. Okay, so that's the expression for this reaction. Okay, second reaction, you have homogeneous equilibrium in aqueous phase. So in aqueous phase, that means you will not have Kp, so you only have Kc, right? So how to write that down? Your products, you have ethanoate ion, I think it's ethanoate ion, CH3COO plus concentration, okay, and then you have H plus over CH3COOH. Alright, so that's your Kc, okay, no Kp. So the question asks for you to calculate the equilibrium constant Kc for the following reaction if at 350 Kelvin the equilibrium mixture, okay, ini mixture awak already in equilibrium, contain 2.50 mole. And then you have mole of oxygen, 3.50 mole. And then you have mole of NO2. It is 0.06 mole. Okay, so your volume is 2.0 dm cube. Right. So it asks for you to, the question asks for you to calculate the Kc. So you're going to write the Kc expression. So C maksud concentration, so squared brackets 2, then you have nitrogen, then you have oxygen, then square, right? Okay, so that means to find Kc, you will need the concentration of NO2, N2 and O2. So since you have the number of moles, right, and you have the volume, can you find the concentration? You can, right?
So concentration of NO2 will be 2.50 mole over 2 dm cube. So kira lah dapat berapa? So for NO2 you get 0.03 molar. For nitrogen you get 1.25 molar. Tunjuk saya nak cepat je kan. So saya tulis terus jawapan 1.75 molar.
So from that you just plug in your values. So NO2 sekarang awak boleh guna round bracket je, tak payah guna square bracket. Square bracket untuk concentration. Masukkan NO2 0.03 square over
1.25. Then oxygen you have 1.75 squared. Okay, tekan calculator. Tekan calculator. Then you will get your answer 2.351 times 10 minus 4.
Ada units tak? Tak ada No units, okay? No units. Because Kc is a ratio. Okay, it is a constant, right? Okay, yang ni actually saya terletak kat sini. Kat sini awak kena guna Kp equals to Kc RT delta N and dia bagi vapor pressure. So you will find out that the vapor pressure of water is equals to the Kp. Okay, tapi saya tak tunjuk sekarang sebab it's supposed to be at the back after you learn this formula. Tapi should I show it? It's quite easy. Okay lah, tunjuk je lah. Okay, I'll show for Kp. First Kp. You have Kp. Okay, so you have liquid water. Right? So for liquid water, you will not include it in your expression. So you're just going to write the partial pressure of H2O. Okay? So liquid ni tak included, okay? Tak included. So what does that mean? That means your partial pressure of water is equal to the Kp, the value, okay? So how to find your partial pressure tukar jadi ATM macam mana?
So 23.8 torr kali dengan 1 ATM over 760 torr. Okay, so cancel dapat berapa? 0.0313 ATM.
Okay, so pressure of water is 0.0313 ATM. So your Kp pula, your Kp will be Janganlah letak apa unit tu. Because Kp is a constant kan. So you're just going to use the value. Right. So sekarang dah dapat value of Kp. So then you're going to use this formula. You will learn later. Tapi dia senang je. Ni macam physics, macam maths je. Masuk-masuk je. So you're going to find Kc. So how to find Kc? You're going to rearrange that formula. Kc equals to Kp RT delta N. Okay, apa delta N awak? Delta N awak is the number of moles of your products minus the number of mole of your reactant. But in this case, we are not going to include liquid. Okay, your pure substance ni. Sebab dia tak ada effect dekat awak punya equilibrium constant. So, as if dia tak ada, so awak punya delta N is just 1. Okay? Okay. R nak guna apa pula? R nak guna apa agak-agak? R guna 0.08206. Kenapa? Because tadi awak change your pressure into ATM. So, if your pressure is in ATM, so the R you're going to use is this one. Okay, tengok unit dia balik. So, masukkan values Kp 0.0313 over R 0.08206. Temperature is, so 25 degrees Celsius sama dengan berapa? 298.15 Kelvin kan? So, masukkan 298.15 Kelvin. Right, and then you have delta N. So, kalau in other cases, you have to buat power of 1 tu untuk semua. Tapi macam 1 je kan, so tak ada beza pun. So, when you kira that, you will get 1.279 times 10 minus 3. Okay? So, dapatlah markah untuk Kp. And then dapatlah markah untuk Kc. Okay? Make sure tak ada unit sebab dia constant. Right. Ini soalan for heterogeneous equilibrium. So, sama macam before, they ask you to find the Kc and Kp. So, let's see. You have calcium carbonate, solid, dapat react, and then dapat calcium oxide in solid and carbon dioxide in gaseous state. So, for Kc, since it is gaseous, okay, this is gaseous. So, you're going to count that in your expression. Yang dua ni, you're not going to count them because they are solid. So, solid, pure substances, they are inactive. They are constant. They have constant concentration, so they don't affect your equilibrium constant. Okay. So, Kc for this reaction is just CO2. Okay? Tak ada solid ya? Okay. Kp pula. Since it is gaseous, so it will have a partial pressure. So, you just have to write the partial pressure of carbon dioxide. Okay? So, second question macam mana? Kc. So, ni ada liquid ni. So, you're not going to include it in your expression. Okay? So, CO over CO2. And then you have H2. Okay? Partial pressure of CO over partial pressure of CO2 and partial pressure of H2. Boleh? Okay, senang je kan? Let's summarize the three things that we learn. We learn homogeneous equilibrium. So, all your products and reactants are in the same phase. And then you learn that heterogeneous equilibrium is where your products and reactants are in different phases. So, you have two types of equilibrium constants. You have Kc in terms of concentration and you have Kp in terms of partial pressure. And ingat, remember that your pure substances like solid and liquid, they are not included in the expression because they do not take part in the reaction, okay? They do not affect the equilibrium constant. So, do not include them in your expressions. Okay, so that's all for part 1 of 6.2. Alright?